In this program, we're going to take a look at how sometimes you can create an array where the actual indexes, like the positions in the array, have a meaning within the program. Now, you don't need to recopy this comment here. This is just a little bit of a model of the array that we're going to be creating, just so that I can refer back to it a little bit later. So the program is called index meaning, and we'll need to put a little bit of randomization into this. So we'll, of course, include time.h here at the top. And we'll start by randomizing srand time null. Okay, so what we're going to do is we are going to be rolling dice, and we're going to take a look at how the numbers that we roll can be tabulated using an array in kind of a meaningful manner. So what we're going to do is we're going to create a couple functions in this program. The first one is just to roll a six-sided die for us. So nothing fancy here. So int die roll, and this one is just going to return random number modulus 6 plus 1. And then the other thing that we're going to do is I'm going to be creating a bar graph with the results. So we're going to be using a function that we created in a previous program. So we're going to make void draw stars. I'll be honest, when I was designing this program, I just did a copy and paste from the previous one, which is one of the nice things about really reusable functions. So we're going to draw a bar of stars. So int I equals 1. While I is less than or equal to the amount of stars that we want to draw, I plus plus, and then we're going to see out a star. And now, different from before, possibly, is we're going to put an endl afterwards. So after I draw the bar, we're going to skip down to the next line. So this will be part of our bar graph. So now I don't have to come back here later. So in the main program, what we're going to start with is the creation of our array. So values, and we'll put the number 13 here. So this is going to have 13 values in it, and I'll show you at the top. So this is actually an incorrect design of this. So if it has 13 values, it does not end at the number 13. So I can wipe this out. So this isn't real. We have 13 positions, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And the fact that we end on the 12 is significant here because we're going to be rolling 2 dice and then adding their numbers together. Now, if you roll 2 6s, you can get a 12. If you roll 2 1s, you're going to get a 2. So we can't really create an array in an easy way that like starts at the index 2. An array's beginning index is always 0. So we're going to have a couple that we won't use here, and then we're going to use these ones to tally how many times was that number rolled. So in order to do that, I need a total here. So int total will be the total of the 2 dice that I am rolling. So step 1, whenever you're accumulating, so this is kind of like an accumulator, but it's actually like 12 or 13 accumulators, a couple that we're not using. So whenever you're using an accumulator, it's always a good idea to initialize all of the values. So we're going to write a little loop for this. So this is our initialization loop. So for int I equals 0, and even though we're not going to be using the beginning values, it costs me very little to initialize them to 0, so I'm just going to include them in this loop. So we're going to use this loop to traverse the array, and then we're going to have the value at position I, so it's going to go from 0 to 12, and we're going to set them all to 0. So what it's going to do is it's going to start on position 0. So 0, it'll go 0, 0, 0, 0, 0, 0. So one at a time, it's going to set all of these values to 0. The next thing that we're going to do is we're going to run our simulation. So this is our simulation. Okay, so now when we're doing this, we're going to have another for loop representing how many trials we want to have. So for int I equals 1, while I is less than or equal to 100, I plus plus. So again, note that when I am counting things from 1 to 100, I use the less than or equals. When I am using positions in array, I use from 0 and then a less than. This is pretty much here this is a style because all the counting starts at 0, whereas my typical human counting starts at 1. So every time we do this, our total is going to be equal to the die roll plus the die roll. So that is 2 6-sided die rolls. And then what we're going to do is imagine that we roll a 4. So then what I want is I want the item in position 4, which starts at a 0, I want it to increase by 1 and become 1. Imagine I roll a second 4, then I want this to become a 2. So the number here is going to be the total, and then I'm going to increase the value in that position by 1. So the way we do this, so I want to reference an item in the values array. Which one do I want to do? Well, I want to reference the value based on the total. So if I rolled a 4, I want to reference the item that is in position 4. So I'm going to increase it by 1. There we go. So if I roll a 4, it'll look at position 4, and then it will increase whatever is in position 4 by 1. Okay, so now imagine I want to display the results. A couple different ways we're going to do this. The first one is we're going to just display the frequencies. So frequencies. Now for this one, we need a loop that is going to go through the array. So I'm going to do a little copy and paste here from my first one. Okay, so I pull that down. And then what I'm going to do is instead of this, I'm going to cout I. And then what I'm going to do is just I'll put a little spacer here. So I'll put a colon, and then on the other side is going to be the particular value that refers to how many times that number was rolled. So if I have a 4 here, this will tell me how many times was 4 rolled. So I'm going to run this, and then we're going to fix it up a little bit. So I'll run this. Okay, so let's take a look. I've got my frequencies table here, 0, 0, 4, 7, 10, 13, etc., etc. So one of the first problems here is that I've got these two values. So the 0 and 1, I can never roll those. Not only that, I don't care what their frequency is because they're not even numbers that I can get. So what we're going to do is for this loop, we're going to start this at 2 instead. So instead of starting at 0, we're going to start at 2 because that is the lowest thing that I really care about in my array. So let's pull this up again. So now it starts at 2, and I get a little distribution here that sort of gets a little bit higher in the middle. This is great. So now what I want to do is I want to turn this into a bar graph, which is a little bit challenging. So what I want to do is I'm going to make my bar graph, say like this one will be the widest row here. So I want to make this one, say, be about 20 stars, something that is going to be about half of the maximum. I'll make this about 10 stars. And then so on down. So what I want to do is I want to find a way to relate this value which will be my maximum, to how many stars should be printed as a result. So I don't have 20 here, I have 19. So I want, for a value of 19, I want 20 stars printed because that is the most. So what we have to do is we have to figure out what is the highest value across our array. So we need a couple things here. So we need a max value. So this is going to determine what is the maximum value that I have. And then I'm going to also have, based on that, I'm going to have a bar length, which is going to be set. And then we'll be printing how many stars equal to the length of that bar should be. Okay, so the first thing is determine the max. So what I'm going to do, max starts at 0. So I'm going to go up to the top here and imagine that we had these values, 3, 7, 8. These are completely fictional. Maybe I'll actually switch that to a 5 and then an 8. Okay. So imagine these were our values. Here's how we would determine the maximum number. Currently the maximum number is 0. So if we take a look at this one, 3 is larger than 0, so our maximum number is going to be 3. Then the next one, 7 is larger than the maximum number, so our maximum will be 7. Then when it takes a look at this position, 5 is not larger than the maximum number, so we'll do nothing. And then here, 8 is larger than the maximum number, so I want my maximum to become 8. So no matter which value it looks at, it's going to go from left to right. It's going to collect a new maximum value whenever it finds something that's bigger. It doesn't, in this case, we do not care what position the maximum number is in. So what we want to do is we'll write a loop that goes across the array. Why am I writing it? I'm just going to do a copy and paste. So once you've got a loop that goes through the part of the array that you want, it's often a good idea to just kind of like reuse that, and then you're less likely to make a mistake. So what I want to do is I want to check to see if the current value that I'm looking at, so if values I, the current value that I'm looking at, is larger than my current maximum number. So if this is the case, wow, I've found a new number that is larger than the last maximum that I had. What I want to do is I want to set that to be the new maximum. So our maximum is now going to become equal to this value we just found. So values I. There we go. So now what we want to do is we want to display graph. So in this case, what we're going to do is we're going to, again, go through all of the elements of the array. And then we're going to display a bar graph for based on the size of the value. So the first thing I have to do is I'm going to determine my bar length. So as I said before, the maximum that I want is I want this to be 20 stars wide. So that is the maximum. And I want to multiply that by, this isn't code, but the percentage of that bar that we should have. So in my previous case, when I have a 19, that's the largest. So I want that to be 100%. But when I have a 10, that's going to be like 50% of the bar. So kind of what I'm doing, this is the maximum, and I want to represent the percentage of that maximum that we're looking at. So here's how we calculate that. We're going to do, first off, we have to have this as a double value. So we're going to typecast it as a double, otherwise it'll lose the decimal. Anytime you're dividing a smaller number by a larger number, if you leave it as an integer, you're going to get a 0. So values I divided by the maximum number. So if we are on the first one, it'll take 3 divided by 20, 3 divided by 20, and then multiply that sorry, 3 divided by 19, 19 was the maximum. 3 divided by 19, and then multiply that by 20, and that's how many stars I will have. Okay, so now what I want to do is I want to print that out. So cout I, and then I'll leave that line, and this is when I want to use my draw stars, and then we'll use bar length as the amount of stars that we're going to draw. So let's run this. We'll take a look at what we have. Okay, so here's what we have. We've got a bar graph. Little problem here is you can see that the numbers 2 to 9, they actually start one position to the left. So I really want to like keep that in line. So here's my fix for that. Before we print this, if I is less than 10, so it's going to be like a single digit number, then I want to see out just a space. There we go. So if I run that again, what you'll see is it'll fix that problem. So now everything has that one kind of straight edge. But this time the graph looks totally different than the last one. And if I keep running this, you're going to find that that is the case. Sometimes it has these weird spikes in it. Apparently I didn't get a single 12 out of 100 tries. So what we want to do is we want to improve the quality of this graph before we finish off with this program. So what I want to do is I want to increase the number of trials, and then it'll look a little bit less jaggedy. So what we want to do is back up here where we have it running 100 times. Let's see what happens when we move it to 500 times and see if it smooths out a little bit. So you can see we've still got a little bit of jagged edges, but it's starting to kind of smooth out, start to look like a slope up and then a slope down. Let's see if what happens when we go to 1,000. So if we go to 1,000, you're going to see, oh, look, it's even looking a little bit more like you could draw a line across all these stars. So we're going to do one last step. We'll go to 10,000 trials here and then watch what happens to this graph. So 10,000 trials, it's virtually a diagonal line that you can draw across these, and that gets to the true values of this. So again, don't forget, you've got a lot of computing power. It takes no extra time to do 10,000 trials. Anytime you're doing a simulation, make sure that you're running it enough times that you get like a really satisfying result like that.